Good morning, students. Welcome to the online classes in physics for standard 11th. Today, we will discuss some mathematical preliminaries, basically the concept of derivatives and slope, which will be very much essential for the rest of our journey in the 2-year curriculum in this physics. The chapters pertaining to mechanics, linear mechanics or mechanics for bodies moving in a plane or three-dimensional motion or rotational mechanics, everywhere we would need the concept of derivatives and some places integration. So it is a wise idea to begin this journey of our 2-year program in physics with some mathematical preliminaries. We would begin today's class with the derivatives. Before directly jumping over to derivatives, first I would like to introduce the concept of slope. Suppose I have a line y is equal to 2x. If we plot the graph of this equation y is equal to 2x, you will get a graph like so. Suppose this is x-axis and this one is y-axis. So this equation will be a straight line passing through origin, and it will be something like so. Y is equal to x will make an angle of 45 degree. It will pass exactly midway between x and y axis. It will be slightly higher. To find slope of this line, what we would do, just take any 2 points on this line. Mark them as suppose A and B. Then from those 2 points, drop perpendiculars on x and y axis. I am starting from very basic concept. Then we'll get a triangle like so. Let this point be C. Now this triangle ABC is a right angle triangle. So the slope we define as tan of this angle. Now this angle is also equal to this angle. Let me call this angle as alpha. Then slope is defined as tan alpha. If this line is straight, it will make some angle with x-axis. Starting from x-axis, if we move in anti-clockwise sense, you will meet this line. After turning through angle alpha, tan of that angle alpha is called as slope. So this is definition. Whenever a curve, a straight line, if it meets x-axis at some point, then tan of the angle made by that line with x-axis, that is called as slope. So m is equal to tan of alpha. Now if you see carefully in this particular figure, if this angle is alpha, this angle is also alpha. So tan alpha will be perpendicular, that is AC, upon base, that is BC. Okay. Now let us assign some coordinates to A and B. A coordinate, suppose I write as x1 comma y1, and B's coordinate I write as x2 comma y2. So that means this point is x2, this point is y2. This is x1, y1 means the x coordinate is x1 and the y coordinate is y1. So what will be AC? AC is this length. Now this total length is y1, this is y2, so this will be y1 minus y2. And BC is this length, so this length is nothing but this total length minus this one. How much is this? X1. How much is this? X2. So this minus this will be x1 minus x2. What is y1 minus y2? We say it is nothing but change in y. What is x1 minus x2? It is change in x. Here I have used this symbol delta. So delta means change. Okay. So this is the concept of slope. Slope is equal to tan of alpha, that we find is equal to ratio of change in y by change in x. If x changes by some amount, y will also change by some amount. So the ratio of delta y and delta x, the changes in y and x, that we call as slope for a straight line. Next, what would happen if the curve is not straight? So suppose we have some general function of x, y is equal to fx. For example, y is equal to x square. Then its graph will not be a straight line. It will be curved like so. This curve we call as parabola. So this is the curve of y is equal to x square. Only a part of it, it will extend this side also. Now here, suppose I wish to find the slopes. Then here, since it is not a straight line, the slope will be different at different points. If I choose 2 points, say this and this, then I can join them by a straight line. Now let this point be x comma y. Let this point be x prime comma y prime. You can choose different symbols, x1, y1, x2, y2. Let this point be A, let this point be B. Then this slope of line AB, as we have discussed earlier, is a difference of y coordinates by difference of x coordinates. From here we will draw perpendiculars, we will get this triangle. So AC upon BC. AC upon BC. AC will be how much? Difference of y coordinates. And BC will be difference of x coordinates. That is again delta y by delta x. But this is not the slope of this graph. It is slope of the straight line AB, the end points A and B of which lie on the graph. Clear? Now what we would like to do, we will start shifting point A closer and closer to point B. Okay. So let's see. I'll draw one more graph. So in general, suppose we have the condition y is equal to function of x. And suppose we have a graph like so. So I choose 2 points as usual, here and here. Let this point be A, this point be B. Then we drop perpendiculars. This point we write as C. So slope of straight line AB, this straight line AB, you can produce it also. Suppose it makes angle alpha. Slope of straight line AB will be tan alpha, and that tan alpha, as we have discussed, will be AC upon BC. And if we name these coordinates, we get delta y upon delta x, where delta y is the difference in y coordinates of points A and B, and delta x is the difference in x coordinates of the points A and B. Now what we do, so this is delta y and this is delta x. This is the concept of slope of a straight line AB. Now we will bring point A closer and closer and closer to B. So point A, we will shift it closer to point B. Suppose A comes here, then we'll get a new triangle. This will be the straight line. This is B, so this I'll write as A dash, new position of A, and we will get a new triangle. So this will be C dash. So here what will be the slope? The new slope will be A dash C dash upon BC dash. Now this was delta y. again this is delta y and this is delta x. So this is a new change in y, delta y, and this is delta x. I write delta y prime, delta x prime. Now this change in y, you can see in this figure, this is delta y prime, this one. This is less compared to this. Now this is important thing which you have to understand. If you bring the 2 points on the graph closer, then change in y, change in x, they will become less. And if you take those 2 points far, then the delta y and delta x will become more. Further, if you bring this point A dash closer and closer and closer, go on doing so till finally point A dash reaches point B. Then what will happen? So in the limiting case, we say as point A approaches, tends to or approaches point B. What is the meaning of this? Point A approaches point B. Then what will happen to delta x? You see, earlier this was delta x. Then for this point, this is delta x. If this point comes here, delta x will further become less. So delta x goes on decreasing. When this point will almost touch this point, delta x will almost become 0. So this is important what you have to understand. So when these 2 points on the curve we take very, very close to one another, we write delta x tends to 0. Now let me make it very clear. I have not taken the 2 points exactly sitting on top of one another. I told approaches. It is very, very close to point B. So delta x is very, very close to 0, but not 0. Almost it is 0. So if this is point B, point A is almost here, we can say. But we have to add that word almost, not exactly. So if delta x tends to 0, then in this situation, the straight line AB, see this line AB, A to B. This was first dash line which I have drawn, then A shifts to A dash. So this is the new line AB. I can produce it also like this. As this point comes closer and closer, finally, at that point, the straight line AB will become a tangent like so. It will touch the curve only at one point, that is this point, like this. Earlier, the line which we were drawing was touching the graph at 2 points. Initially, it was touching at these 2 points. Then it was touching at these 2 points. But now when this point has approached almost towards point B, almost those 2 points are one and the same. We say the straight line will now touch the graph at exactly one point. Such a line, we know, it is called as tangent. Okay. So in this situation, the straight line AB becomes tangent to the curve at point B. And this slope of straight line AB, it becomes, instead of slope of straight line AB, because A has approached B, so we talk about slope of tangent at B. Tangent at B. Earlier that line was not tangent, now that line becomes the tangent. And what will be that slope? The slope of this tangent will become equal to same thing, delta y by delta x. But as we have discussed earlier, delta x now becomes very, very small. Earlier delta x was so very big, it goes on decreasing. When this point comes very close to this point B, delta x will become very, very small. That we indicate by writing limit delta x tends to 0. Now this is a mathematical notation. How will we read this? limit delta y by delta x tends to 0, or limit delta x tends to 0, delta y by delta x. It is the limiting value of delta y by delta x as delta x approaches 0. And this, in the language of mathematics, we call it as dy by dx. Dy by dx is nothing but, we write it as derivative of y with respect to x. Okay, this is a very important concept. So what we discussed is this is summary. Dy by dx is limiting value of delta x tends to 0, delta y by delta x. Delta y by delta x, conceptually you should understand, it is the graph, it is the slope of the graph. Slope of a straight line, endpoints of which lie on the graph. And dy by dx is also slope. Which slope? Slope of the, yes, tangent. So geometrically, dy by dx is, or it represents, slope of tangent to a curve at a point. And how do we find slope? Slope is equal to tan alpha, where alpha is the angle between the tangent and x-axis. I have told you in the beginning concept of slope, that is tan alpha. So let me now recapitulate the entire thing. What you should remember is this. Let me draw one more graph. Suppose this is y-axis, this is x-axis, and this is a curve. This curve is y is equal to function of x. Now, if you are asked to find its slope at some point, say this. Different points on the graph may have different slopes. At this point, to find the slope, what we will do, we will draw first a tangent. Tangent will be such a straight line which will touch this curve at exactly one point. Touch. This is not tangent. It is not touching. It is intersecting. So there is a difference between the words touching and intersecting. So if this is the curve, we will draw the tangent like so at this point. Then that tangent will intersect x-axis at some point. So produce it. This is the angle made by the tangent with x-axis. Let this angle be alpha. Let this point be P. And this graph is y is equal to fx. So we write slope of y is equal to fx, this curve, at point P. Let me name this point as x comma y, is equal to slope of tangent at P. Now how do we write slope of tangent at a point? Slope of tangent at a point is nothing but tan alpha as per this figure, and this is also equal to dy by dx at point P. Okay, so when you see this new term dy by dx, it is simply a ratio of change in y to change in x. When we have a function y is equal to fx, for example, y is equal to x square, if you change x, y will also change. The change in y by change in x, that will be called as delta y by delta x. Now, if you change x by a very small amount, delta x tends to 0, then that ratio delta y by delta x becomes dy by dx. So delta y by delta x, limit delta x tends to 0, that we write as dy by dx, and that is called as derivative of y with respect to x. So geometrically you should remember, students, that dy by dx is nothing but slope of tangent to the curve at some point. And mathematically, dy by dx is given by this formula: limit delta x tends to 0, delta y by delta x. So this is geometrical interpretation of derivative. Now see, suppose we have y as a function of x. If x changes from x to x plus delta x, so delta x is a small increment in x, then y will also change from y to y plus delta y. Instead of y, we can write fx. So fx will change from fx to f of x plus delta x. All these things are same. Earlier the value was x, now it is x plus something. Y was y initially, now it will be y plus something. And f of x, which was earlier fx, it will become now f of x plus something. So y is equal to fx, y plus delta y is equal to fx plus delta x. Now how we have defined dy by dx? This is limit delta x tends to 0, delta y by delta x. What is delta y? Delta y is change in y. Change in y is final value minus initial value. You can see y will cancel delta y. What is y plus delta y? It is f of x plus delta x. I forgot to write this limit. Limit delta x tends to 0. Y is, so this is the mathematical definition for derivative of a function. Okay, let me try to make you understand with the help of some examples. Two examples I'll work out. See, our purpose is here not to discuss calculus in details. Basically, why we are doing these things, and today we will discuss applications also. We will introduce these things in physics. Velocities, accelerations, these things can be written as derivatives in the form dy by dx of some quantities. So we will see them just in 5 minutes. We'll arrive there. This is the working formula. You should remember this particular formula. Suppose I have a equation y is equal to x square. I have to find dy by dx. This is the question. So we will use this formula. So I am writing directly dy by dx will be limit delta x tends to 0, fx plus delta x minus fx by delta x. Now we will choose x square as fx. So let fx is equal to x square. Fx is same as y. Okay. So y is x square. Instead of y, we can write let fx is equal to x square. So let us now calculate. So this becomes limit delta x tends to 0. In denominator we have delta x, f of x plus delta x. See, fx is equal to x square. So minus fx, this will become minus of x square. Now instead of x, here we have x plus delta x. So fx is equal to x square. So f of x plus delta x will be equal to x plus delta x whole square. So we'll put that value. Now to solve this limit, how to solve? Try to simplify this using algebra. Cancelling positive and negative, then cancelling numerator and denominator if possible. Try to simplify as much as possible. After you have simplified this expression, in the last step you will put delta x is equal to 0. See, when I say delta x tends to 0, it means delta x has approached to 0. It is very, very small, very, very small. But don't put delta x is equal to 0 in the very beginning. If you try to put delta x is equal to 0 here, see what you will get. Delta x is 0, so this becomes x plus 0, that is x. X square minus x square cancels 0. In numerator we'll have 0, and in denominator also we'll have delta x, which is 0. So it is 0 by 0 form. So we have to simplify it. So is equal to limit delta x tends to 0, a plus b whole square, a square plus b square plus 2ab, and then minus x square divided by delta x. Minus x square plus x square cancels. So how much is obtained? Limit delta x tends to 0. Now delta x we will take common. So what will be left? Delta x plus 2x divided by delta x. Be careful. Now when we cancel this delta x and delta x, we are able to cancel because we know that delta x is not 0. Delta x tends to 0 means delta x is very small, but not 0. For example, it is 0.0000001. So 0.0000001, 0.0000001, they can cancel, no problem in that. So what is left behind is limit delta x tends to 0, delta x plus 2x. Now I told you in the last step, when no further simplification is possible, put delta x is equal to 0. So 0 plus 2x is equal to 2x. Why we do that? Here I was saying don't put delta x is equal to 0. Here I am saying put delta x is equal to 0. Putting delta x is equal to 0, actually it is with reference to this. Delta x, as I told, 0.00 something, many number of zeros than 1 or something. This will be very small compared to 2x. So with respect to 2x, since it is very less, that's why we are neglecting this term with comparison to 2x. Then you might ask, sir, why we did not put 0 here? Observe this carefully. Suppose I have 2 plus 0.000001. I can write this as nearly equal to 2. I have assumed this to be 0. But if I have 2 into, or if I have 0.0012 by here, if you take it as a 0, then this is 0 by 0 form, which is not defined. So you can write 3 into 0. Here I will not write that 3 into 0 as 0, because I have something in denominator, and we find that they are not equal to 0. They are very small, but this is also very small, and this is also very small, and this ratio is not small. 0.000001 is a very small number. This is also a very small number, but this ratio is not a very small number compared to 3. Suppose this is plus, it can be anything. So these two will cancel and it becomes 1. 3 plus 1 becomes 4. See the difference here. If this ratio were not present, I would have written 3 plus 0.0000001 is nearly equal to 3. So here we are neglecting this because it is added to a number which is very large. Here there was a ratio, delta x is very small, not equal to 0. Delta x is very small, not equal to 0. So because they are same, we can cancel them. We must cancel them. Okay. So try to ponder over these discussions. I will do one more question. So what is the result? The result I will put here. We got derivative of x square, dy by dx is equal to 2x. We got dy by dx is equal to 2x. We will write it in another fashion. D by dx of y. Instead of y, I will write x square as per the question. One last question more I'll do, and then we'll see its practical application. Instead of x square, suppose we have x cube. So let's quickly see the method. dy by dx is limit delta x tends to 0, fx plus delta x minus fx by delta x. Okay, so is equal to limit fx is x cube. We choose y to be fx, so fx is equal to x cube. So what will be f? X plus delta x. In place of x, we will put x plus delta x. So this becomes x plus delta x whole cube. Now we have to solve this particular expression. This is a plus b whole cube. So this is a cube plus b cube plus 3a square b plus 3ab square. And there is minus x cube whole divided by delta x. You can see here minus x cube and plus x cube will cancel. So what is left behind? Limit delta x tends to 0. I'll take delta x common again. So what will be left? Delta x square plus 3x square plus 3x delta x. These three terms. And whole divided by delta x. This much is left behind. So is equal to limit delta x tends to 0. I have taken delta x common in the numerator. This is numerator. So these two terms, delta x and delta x, will cancel. So what is left behind is this delta x square plus 3x square plus 3x delta x. Now see, we have nothing in the denominator. Now what I have told, delta x is a very small, negligibly small entity. 3x square, in comparison to 3x square, this term delta x square and this term 3x delta x will be neglected. In other words, we will set delta x to be 0. So the answer will be 3x square. So this we will neglect, this we will neglect, and we will be left with 3 times x square. Okay. So what is the result? Our answer is derivative of x cube is equal to 3x square. Derivative of x cube, d by dx of x cube is 3 of x square. Now you see, these two formula we try to compare. Likewise, we can obtain the derivatives of x power 4, x power 1 and so on. In general, that also can be done in mathematics, but we will not derive it. So in general, d by dx of x to the power n is given as n times x to the power n minus 1. Okay, so this is one important formula of derivatives which we will need. You can see, suppose we write d by dx of x square. So n is the power, so power is 2. That is n. So our n is how much? 2. So 2 into, then x to the power n minus 1. What is n? N is the power. So 2 minus 1. What is 2 minus 1? 1. So how much we get? 2x. How much we got earlier? 2x. Likewise, d by dx of x to the power 3. Use this formula. Our power n is equal to 3. So this becomes 3 into x to the power 3 minus 1. What is 3 minus 1? 2. So we get 3 times x square, which is same as what we had done earlier. So this is about some idea. These are some ideas about derivatives of a function. Now the question arises, why are we reading this? Today I have told you only one formula, that is this one. Okay. Uh, in addition to this, so this I write as 1. In addition to this, I must specify here at this point, derivative of some constant is equal to 0. Now when we say some constant means it's not changing. Suppose y is equal to constant. It is fixed. If it is fixed, y will never change. So delta y will be 0. Delta y is a change in y. I am saying y is fixed, y is constant. So y is not changing. Y is not changing means delta y is 0. And that's why the derivative delta y by delta x, whether it's limiting case or not, will always be 0. So derivative of constant is 0. Okay. There are some other formulae which you can find in your textbooks. I am just listing those formulae. They can be derived in similar fashion, but you need to have some mathematical knowledge on trigonometry or some other algebraic identities. Just I would like you to note down these relations. D by dx of sin x is cos x. In this chapter of mechanics, we will mostly need these two. These things we will not need, but anyway, you can just note down them. Derivative of tan x is sec square x. Derivative of cot x is minus cosec square x. And those who have opted for mathematics in +2, they will read these things in details, more details. Sec x and then we have cosec x. So these are some of the trigonometric relations. Then we have some more. Derivative of log x, ln x is 1 by x. Derivative of e to the power x is e to the power x. I think this much is more than sufficient. But as I told students, in this particular chapter of mechanics, where we talk about displacement, velocity, acceleration, forces, etc., mostly we will need these two. Then in case of dissipative forces, we might need this formula, this one. Then when we discuss about oscillations in 11th class, at the end, we'll discuss about waves and oscillations. There we will need them also. So it's better to remember all of them. If some other things are needed, wherever needed, we will discuss them in details over there. So please note down this formula. Now we will discuss their practical utility, so that we can understand why we are reading these quantities, these concepts. In physics, some terms you are already acquainted with. So applications in physics for our daily life. Velocity. Velocity is expressed as a derivative of position with respect to time. So we write v as dx by dt in one dimension. One dimension means what? Suppose there is an ant. That ant is allowed to move only along a straight line. That ant cannot move left and right, it cannot fly. So that motion we will call it as rectilinear motion or one-dimensional motion. So if she starts at some position and moves, then her position x will change with time. Then her velocity, that is given as displacement by time. So change in position by time. So average velocity we define as v average is equal to change in position. Change in position we will write as delta x by time interval. Time interval we will write as delta t. So this can be written as x2 minus x1 by t2 minus t1. You know from your earlier classes the concept of average velocity, displacement by time. So if you are asked to find instantaneous velocity, instantaneous velocity means what is the velocity at this particular instant when the ant crosses this point. Velocity at an instant. When we say an interval, interval means from 2 seconds to 6 seconds suppose. So there is an interval. But when you talk about a instant, at t is equal to 2 seconds. So the interval is 0 there. So here interval is delta t. For finding instantaneous velocity from average velocity, we will go on making this delta t smaller and smaller and smaller. So this will become limit delta t tends to 0 delta x by delta t. Now let me remind you students, we have discussed earlier limit delta x tends to 0 delta y by delta x is equal to dy by dx. Likewise, here delta we will replace by d. Okay, so delta x by delta t, limit delta t tends to 0, this will become dx by dt, which is what I have written here. This is application number 1. Likewise, the average acceleration and instantaneous acceleration we can understand. So average acceleration, a average in one dimension we are discussing right now, is defined as change in velocity by time interval. We write v minus u by final velocity minus initial velocity by time interval. Okay, so this is average acceleration. Instantaneous acceleration, if you want to find, the instantaneous acceleration we will denote by a, and that is the acceleration at a particular instant. So the interval of time has to be very small. How small? So that we can assume it to be 0. So limit delta t tends to 0. Delta v by delta t. So as we have done earlier, this becomes nothing but dv by dt. So 4 things you should remember, students. Average velocity is delta x by delta t. Instantaneous velocity is dx by dt. Average acceleration is delta v by delta t. And instantaneous acceleration is dv by dt. Based on this, I will end up today's class by discussing one simple example. And this one example will clear all your concepts pertaining to what we have discussed. So the position x of a particle moving along a straight path varies. What varies? This position x with time, as x as a function of time it is given. It is given t to the power 3 minus 2t square plus t minus 1. As time is changing, the position of the particle is also changing. Find number A, instantaneous velocity at t is equal to 1 second. Instantaneous acceleration at t is equal to 2 seconds. Average velocity during the interval t is equal to 1 second to 5 seconds. Let us try to understand this question. The first thing that is given in this question is this. Number A, what is asked in the question? Instantaneous velocity. What is the formula for instantaneous velocity? dx by dt. Now, before I discuss that, I should have told you earlier, if we have sum or difference, product I will not discuss today. If we have sum and difference of two functions, then the derivative of the sum or difference is equal to sum or difference of the derivative. For example, I'll stop for 2 minutes. Let u and v be functions of x. Then derivative of u plus v is derivative of u plus derivative of v. Likewise, derivative of u minus v will be du by dx minus dv by dx. One more thing I would like to write. Derivative of some constant, say k, times u. K is a constant and u is a function of x. So derivative of constant into a function is equal to constant into derivative of that function. For today this is sufficient, so please you should remember these relations. We will use them here. Our instantaneous velocity is dx by dt, so this becomes d by dt of x. X, put the value t cube minus 2t square plus t minus 1. For your help, because this is first class, let me remind you, derivative of x to the power n, I have told n into x to the power n minus 1, and derivative of constant is 0. In the next step, what I'll do, I'll use this particular rule or this rule. So if we have sum, individually you have to find the derivative, you have to add. So this becomes, here there are 4 terms, so d by dt of t cube minus d by dt of 2t square plus d by dt of t minus d by dt of 1. Simplest one, 1 is a constant, derivative of constant is 0, so this becomes 0. So I'll rub this. This becomes 0. Then you see this one. When a constant is multiplied to some function, that constant we take it out of the derivative. So k we can take it out. Here this constant 2 is there. So 2 we can take it out. So minus this 2 will take it out. What is derivative of t cube? Use this formula. Power is n, so this will become 3 into t to the power 3 minus 1. 3 minus 1 is 2. Minus 2 into derivative of t square. So derivative of t square will be power 2 into t to the power 2 minus 1, that is 1. And this is t to the power 1. So 1 into t to the power 1 minus 1. What is 1 minus 1? 0. And what is t to the power 0? 1. T raised to the power 0 is 1. So this is the answer. So what we get? 3t square minus 4t plus 1. This is the expression for velocity. But they are asking what is the instantaneous velocity at t is equal to 1 second. This is a general formula. So at t is equal to 1 second, velocity you can find by putting t is equal to 1. So t is equal to 1 here, t is equal to 1 here. So 3 into 1 square becomes 3 minus 4 into 1 is 4 plus 1. 3 plus 1, 4. 4 minus 4, 0 units. So velocity at t is equal to 1 second will be 0. Next, we have to find acceleration at t is equal to 2 seconds. Acceleration is given by a is equal to dv by dt. A is equal to dv upon dt. Now velocity we have already found here. So this I will write as d by dt of this value. I'll put 3t square minus 4t plus 1. Simple. And then again we will follow the derivatives rules. We will segregate them. So d by dt of 3t square minus derivative of 4t plus derivative of 1. Can you guess which of these three will become 0? This one, because 1 is a constant derivative is 0, so this will become 0. 3 will come out of the derivative. 4 will also come out of the derivative because they are constants. So what will be left? Derivative of t square will become 2 into t to the power 2 minus 1. Derivative of t to the power 1, so this becomes 1. 1 into t to the power 0, t to the power 0 is 1. So what we get? 6t minus 4. Now this is the general instantaneous acceleration. We have to find its value at t is equal to 2 seconds. So at t is equal to 2 seconds, acceleration will be obtained by putting t is equal to 2. So 6 into 2 minus 4, 12 minus 4, that is 8 units. If the system is SI, we will write 8 meters per second square. Okay. Now the third question, third part. We have to find average velocity during the interval t is equal to 1 second to t is equal to 5 seconds. Now how do we find average velocity? See, average velocity is given as change in position by time interval. That is x2 minus x1 by t2 minus t1. t1 is 1 second, t2 is 5 seconds. I have to find x1 and x2. What is x1? x1 is the position at time t1. t1 is 1 second. The x1 is position at time 1 second. Position is given. At 1 second, what will be the position? Put t is equal to 1. So x will become how much? 1 cube minus 2 into 1 square plus 1 minus 1. So 1 minus 1 becomes 0. 1 minus 2 is equal to minus 1 units. x2. x2 is the position at time t2. How much is t2? 5 seconds. So x2 is equal to 5 cube minus 2 into 5 square plus 5 minus 1. So this is 125. This is 5 square, 25 into 2. Then 5 minus 1, 4. So 125 minus 50 is 75. 75 plus 4 is 79. And therefore, average velocity during the given interval from 1 second to 5 seconds, we will use this particular formula. x2 minus x1 by t2 minus t1. So x2 is 79, x1 is minus 1, t2 is 5 minus t1 is 1. So in SI system, the unit will be meter per second. So this becomes 80 by 4 meters per second. Now this can be simplified to 40 by 20. This 80 by 4 is 20 meters per second. So today, students, we discussed a very important tool of derivatives. We discussed that velocity is a derivative of position with time. Acceleration is a derivative of velocity with time. We understood that derivative basically, geometrically, it means slope of tangent to the curve at a point. We also discussed how do we find the slope. Please revise all these contents properly. In the next class, we'll see another aspect of calculus, that is integration or the integral calculus. So we'll meet again in the next class. Please revise the contents carefully. Till then, take care and read well. Thank you, students.